Hi everyone. So in this video, we're going to talk about conditional logic. Conditional logic is one of the last big pieces we need in our coding tool belt to be able to express complex programs. Specifically, we're going to introduce the if statement and look at a couple varieties of if statement that allow us to create different versions of our program based on information that we store. We're going to look at how this relates to the Boolean variables that we've already learned about and talk about a couple ways that we can use if statements when we are writing code. So the big idea of an if statement, of this conditional logic, is that sometimes when we're writing a program, we have some decision point. We have a choice that the user has to make, a menu where they can pick different options, or a branching path where, based on user input or the contents of a file, we might have two different sets of instructions that represent different possibilities. This is very different than the programs we've written before that pretty much run from top to bottom, where there's an instruction 1 and then an instruction 2. Even when we had functions, you could copy paste the contents of a function and unwind them and still end up with a very linear top to bottom list of instructions. If statements are actually going to create a fork in the road, two different instructions that come after them based on a Boolean value. And Boolean values are really going to be the key here. We've looked at how they let us store yes or no, true or false in a variable. And it turns out the first thing an if statement is going to do is use that Boolean as a very simple switch. Like if you think about railroad tracks where you can pull the lever and swap over to the other track, that's the role that these Boolean variables are going to take in our if statements. So the most basic form of this is a plain old if statement. And with this plain old if statement, there are two key parts to think about. Every programming language, no matter how it writes if statements, is going to have a Boolean condition and then a body block. So the first part of this, the Boolean condition, is any expression that evaluates to a Boolean value. So this could be a variable that has a Boolean in it. If you've already stored is answer correct as a variable with an equals true or an equals false, you can put if is variable correct and then the instructions that you want to follow in there. This could also be a function call that you make. You could say if file exists, parentheses, some file. And when that file exists, that function hopefully returns true. If it doesn't, it returns false. That still evaluates to a Boolean value, so that's okay. We could even use our Boolean conjunction, say if it is sunny and it is rainy, then our instructions inside of here, whatever we put in that Boolean condition, as long as it ends up being a true or false, when the computer's finished processing it, that's fine. And what this condition is going to do is it's going to be the gate that decides whether we follow the instructions that come inside, the instructions from our second piece, the body block. So after we have our condition up top, inside of a block, we are going to put all of the instructions that the computer should follow if and only if your Boolean expression is true. So in Python, we represent a block with indentation, much like when we're writing a function and we have to say all the instructions that are part of this function get indented. In the same way, all of the instructions that should happen when our Boolean condition is met will all get indented, pressed in a little bit, so that the computer can recognize, well, where is the rejoining point? Because the idea is that this detour is just temporary. You've got something that happens for a while, but eventually you don't want to have like two different sets of files for the entire rest of the program. So we eventually join back together after you unindent your code. And so what that leaves us with is a flow chart of our program that looks something sort of like this here, where we're following our instructions one after the next. Eventually, we hit an if statement and we put this if keyword in front so that we can identify it. And then after if, we put our Boolean expression, whatever that condition is that we're checking for. If it's time to wake up, so wake up time is true, then when that variable is true, we're going to follow the indented instructions. So we did everything up here, we did our if, and then the next instruction would be this first one inside the block. Say it's going to turn on my alarm clock. However, if the variable or the function call or the expression here ends up being false, then what the program does is it skips all of the indented instructions entirely and it jumps to the bottom of that block. And then it just starts doing whatever comes after. So there are two paths now through our program. Either we do the stuff up here, then the condition, and then everything indented, or we do the stuff up top, and as soon as we hit that if, we jump all the way down. And this lets us already encode a lot of different real world situations in a program, as long as we can figure out some way to identify, well, here is something that will be true. Then if you can figure out that thing that will be true, you can say what needs to happen. And you might need multiple of these if statements. You know, you have if the first thing I'm testing for, and then later on if there's some other thing I'm testing for. And it lets you create all of these little detours where you've got some extra bit of code that needs to happen when that condition is met. If my file does not exist, then create a new file and then keep going. If the person got too many wrong answers, kick them back to the beginning of the quiz and then start over. Maybe call a function to go back to the start of the program. If we need more information from the user, then we pause and we ask for input. Print another question out for them. As long as we can find some variable or function call that will be true, then we can add in whatever extra instructions we want. And that's really the power of this if statement. So what I want to do now is talk about a couple other variants of the if statement that really don't change the power that we've got. This is pretty much all we need, but they make it easier to do some common things that we often need to do when we're writing conditional logic. So the first one we're going to look at is the else statement. So an else statement is a second block that comes immediately after an if. So I might have if my condition, a whole bunch of indented instructions, and then the very next thing when I unindent is else. And else goes by itself. In Python, we put a semicolon after, or not a semicolon, a colon after it to say, yep, this is the end of the expression. And then with an else, we put a second indented block of instructions. And this word else behaves pretty similarly to the way that we use it in normal communication, in regular language. If I were describing a hypothetical to you, I would say, well, if there are eggs at the store, then buy me some eggs. So that would be our normal if statement. If eggs are present, however we test that, then here's the instructions that you do. Otherwise, else, if there are no eggs, then buy me something else instead. What this else block does in our program is it says when the Boolean condition was not met. So instead of our if statement skipping to the very bottom and immediately joining together when our Boolean condition is false, instead it jumps down to the first instruction of the else. So now we have two different paths to our program. We're coming down from the top, we hit our Boolean expression, our condition here. If it's met, then we're going to keep going through this first block, and at the end of this block, when we get to an unindented line, we skip the else and go to where they join up. Otherwise, if we're coming from the top, we hit this expression, and the expression is false, then we skip the first block, go to the second block, and then we're at the bottom, so we join up. So what our else statement lets us do is create a second set of instructions, create the second path when our condition is not met. This would actually be almost the same as us putting if and then a not, and then in parentheses everything from our original Boolean condition. If something in here changed what those variables were, then it would behave slightly differently. But that's a great way to think about the else statement, is it's if not this first condition, then do these. And so when we're using the else, we always do one or the other. Never both, never neither. But this gives us a way to say, well, either do this or that, instead of just adding something in that is a little quick detour. Now we actually have two separate paths, which is something we very frequently want when we're creating some branching choice in our program. Either you picked this or you picked that, and our program will follow whichever set of instructions are relevant for you. So that is the else block. What I want to look at now is one more similarly named little instruction, the else if, or in Python, it's just called the elif. They contract it a little bit more. What the else if, or elif, is going to do is let us create a second Boolean condition. With our elif, we have our first normal if statement, if some condition. Here's what I want you to do. You have the instructions that follow when your variable is true. Immediately after the if, or immediately after another elif, you can put elif and then put a second condition. This lets you actually use the Boolean expression again. You can come up with some other thing you want to test for. If it's 7 a.m., then, lift my curtains a little bit. Elif, it's 8 a.m., then start playing my alarm clock. Elif, it's 9 a.m., play the alarm clock really loud because I should have already left. What the elif allows you to do is to test for second, third, fourth things that you want to test for. And so the thing that you're thinking to yourself right now might be, well, why do I need elif? Why don't I just write a second if statement? If my first thing, here's what to do. If my second thing, here's what to do. So what is unique about elif statements is when your program encounters this chain of conditions, it's only going to keep going until it finds the first match. If this first condition, our green one here, is met, it does that, and then it skips all the way to the bottom of all of the elifs, goes to the very end of our sequence, and that's where it joins up. It doesn't even try this second one here. And that is useful for us when there are 3, 4, 5 choices, we can say if choice 1, elif otherwise if it's choice 2, otherwise if it's choice 3. And once we know, hey, they've checked choice 1, that's the one that they picked, we can skip all the rest. It's a little bit more efficient, and it makes it so we don't accidentally end up in a situation where we go down more than one of these paths when that would be impossible. So this name, else if or elif, actually comes from the fact that in some programming languages, it's not a real bit of syntax at all. Our else if is the same as using our normal if statement for the if. That has been the same in all of these versions. But then, when we write our else, putting an if inside that else, nesting this second if, that's going to behave the same as our elif here, because if the first one is met, here's what we do. If the first one is not met, then we go to the else, and the first thing in here is check, okay, well, if this second condition is met, do this. Otherwise, skip to the end. So that is a good way to think about else if, and sometimes this is even something you want to do anyway, having an if statement inside an if statement if there is another little branch or choice where you've got one fork in the road and then another fork in the road after it, going down further and further through a chain of possibilities. However, you do have to be careful, because this is very different than if the if statement was not indented. If you're putting an else on one or both of these, you have to be careful which thing you're actually putting the else on, what that actually means for your program. You are allowed to use both an elif and an else on the same conditional instruction. You can have if, and then an elif, and then an elif, and then an else. But when you do it, you always have to put the else at the very end, because remember, as soon as one of these branches matches, it doesn't try any other ones. So if you put the else second, right after our first if, your elifs will never even be checked. In fact, in most programming languages, it will tell you it's an error, a syntax problem entirely. But that is our introduction now to if statements. Like we said, these are great when you want to test something. It allows your program to be a little bit more reactive, where you can actually try and test for a condition, respond to a user, check that you're not about to do something horribly wrong before you do it, instead of just trying it and seeing if the program crashes. So this is a great tool to have in your tool belt. Definitely experiment, play with this new instruction, because it is one of the most common extra bits of control flow, ways we can adjust what order instructions happen in our program. So that is our introduction to if. From here, we're going to be looking at while. So that will allow us to do something similar to if, but with some repetition. So look forward to that, and I'll catch you all in the next video.